Sorry, in the last video I did not realize my webcam was on, but it's okay. It wasn't worth re-recording, so you got to watch my ceiling for half the video. So the upper and lower sums are much like what the ancient Greeks learned several centuries ago, that we can find the areas of geometrically challenging shapes by subdividing them into familiar shapes. The more shapes we use, the better our approximation is. So you notice that at one time a circle was challenging for the Greeks. Which figure would give a better approximation for the area of the circle? Why? Well, we would probably pick circle 2, right? Because there's more triangles in it. So that's what I would write here. I would say circle 2 because more triangles. And because, look, there's less gaps. Gaps between circle and triangles. Or there's less space, something like that. All right, so we are going to do a Desmos activity, okay? So I would put, I posted the link in Google Classroom, so I would kind of try to follow along, maybe do a split screen of what I'm doing here. I'm going to kind of step you through it. So consider this function on the interval. Find two approximations of the area lying in between the x equals -5 and x equals 0 to 2. Using 5 subintervals that are rectangles, use the Desmos activity to find the following approximations. Sketch the rectangles for each approximation. Okay, so we're going to do the best we can to put this into Desmos here. So I'm giving you this file, okay? And you'll notice in this file, it already is kind of doing the Riemann sums for us. So we can redo our function that's on that line. We can decide where our left endpoint is starting, okay? We can also decide where our right endpoint is starting, okay? And then if we change this, if you read the instructions, let's set C equal to 0 for left, set C equal to 1 for right, and C equal to 0.5 for midpoint. So if I just bring this to 0, now I've got the right-hand sum. To 1, I've got the right hand. If I bring it to 0, now I've got the left-hand sum. And then it will also divide it, and we can change the number of rectangles that we have as subintervals. And then it will actually give us the summation of it. So we're going to be able to do that all. And it also tells us the integration, but we're going to go with the summations today for our purposes. So I'm going to go ahead and type in the function that they gave me, which was -x² plus 5. Okay. And then it tells us that we're going to have the x-axis, x equals 0 to x equals 2. So I know that my left endpoint is in fact 0, so I want this to be right at 0. And then my right endpoint is going to be at exactly 2. So if I can get that on exactly, there's exactly 2. Okay. And then it says that I'm going to start with the right side. So I'm going to start with, because that happens to be the first picture. So I'm going to put it at 1. And then it wants only 5 rectangles. So I'm going to go 5 rectangles. Getting there. There we go, 5. Okay. And then you'll notice that there is my calculation. It's 7.36. So let's record that over into our notes. So I know that I want right rectangles. 1, 2, 3, 4, 5. It looks like we're right at 5. So I'm going to go right rectangles. And let's say, did it come under like that, like it was supposed to? Yep, it's coming underneath. Okay, so right rectangles. So like that. And again, it always doesn't hurt to practice drawing these things, because it always helps for that underestimate, the overestimate. And then we know that the approximation was, what did we say? Totally lost it. 7.36. So this one, get back here, is 7.36. Okay, now we're going to do the left side endpoint. So let's see what that looks like in Desmos. So I'm going to switch it to here. That was not what I was going to switch. I switched the wrong thing, didn't I? I still want 5 rectangles. Okay, I'm going to switch it back here for my left. So now it looks like my rectangles are a little bit above, and I got 8.08. So I know it's 8.08. And if I was going to draw a picture, I'm going to be from the left side, hit the height 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 from the left side. So in the example above, we could say that the area we computed using the right side endpoints is the lower sum because it produces the area that is less than the actual area under the curve. Likewise, the area we computed using the left side endpoints could be called the upper sum. This is because it produces an area that is greater than the actual area under the curve. But you don't want to assume that the right endpoints always produce a larger sum. It all depends on whether f is increasing or decreasing. So hopefully you remember this from last year. And I didn't give you really anything here, but we're going to sketch them really fast. So if we had a curve, that was a decreasing curve. If we had an increasing curve, so something like this, okay, and we're going to come at it from the right and then the left over here, okay? And let's just say we do four rectangles. So coming at it from the right side, I'm here. I don't know, like that, 4. So 1, 2, 3, 4. So you notice that this one is above. This would be the upper sum, which we would have said is an overestimate. And then this one here coming at it from the left, well, there's 1, let's go 3, 4, okay? So 1, 2, 3, 4. This is definitely the lower sum this time, which we would have called an underestimate. All right, that's where we're going to stop this video. The next one's going to probably be just a touch longer.